Hello, good evening. My name is Yogendra Kumar. I'm a maths teacher at askIITians. Okay, today we are going to do lecture number 2 on our chapter, which is congruency of triangles, right? Basically, we are studying congruency in all the shapes, but now we are going to deal with the triangles more. So that's why we are saying it congruency of triangles, right? So last class we have seen what is congruency, what is similarity. We have seen like what type of congruencies we have, right? We have seen different examples and we have practiced enough, right? So now we are going to do our discussion further here. Okay, we are going to see what are the criterias of congruency. What is the basic meaning of this thing is what, like, on what basis we can say that two triangles will be congruent, right? So let me do the working here and let me show you, right? Okay, so chalo guys, okay, let's get started. So you can see, okay, this is our chapter congruency of triangles, right? So we have these topics to cover today. What is SSS criteria of congruency? What is SAS criteria of congruency, ASA, and RHS? You can say here one more congruency here we can add here. You might have remembered, okay, that in the last lecture, if you watched previous lecture, I have shown there AAS congruency also, right? AAS criteria also, right? So that is nothing but that is same as ASA congruency only. If we have ASA congruency, we can say that is AAS congruency also, right? So let's see that, okay, like how it comes. So basically what we are saying, if these criterias are fulfilled, if these criterias we fulfill, so we say that our two triangles are congruent to each other. That is what the main idea, right? So let's see, like we need to define them, we need to understand them correctly. Okay, so let's get started. So first criteria is pretty much simple, very very simple. Okay, it is what, like what we say here, the triple S similarity, not similarity criteria, we say congruency criteria. Similarities also we have, right? We have this similarity also, but in that ratio we do. Here what we are doing, triple S congruency criteria. Okay, we should write it congruency criteria, right? This is congruency criteria. State that if three sides of one triangle are, okay, it is pretty much written for the similar triangles here, but what we are discussing here, we are discussing congruency, right? So let me just show you, okay, here from your textbook only. This is your textbook, right? Okay, so criteria for congruency of triangles, let me write down here. So what is it? Okay, let's understand this from this example here, which is like pretty good example to understand it, okay, clearly here. So what they say here, we make use of triangular structure and the patterns of frequently patterns in frequent day-to-day life. So it is rewarding to find out when two triangular shapes will be congruent, right? So if you have two triangles, out of them, okay, one, like, okay, what we can say, like, okay, let's understand this, right? How we say this is triple S congruency we are discussing here. So there are two friends. Okay, let me explain you this way. Two friends are there, Appu and Tippu. Okay, I think you can understand the names Appu and Tippu. There are two friends. Okay, you can take any other name also if you want. Okay, play a game. Appu has drawn a triangle. He has drawn a triangle. Suppose this is the triangle he has drawn, and has noted the length of each of the sides and measure of each of its angles. So, right, he has drawn a triangle whose sides and all. Okay, you know how to draw the triangle, right? I believe you know. If you want to practice online, okay, if you want to practice online, what you can do, you can take the help of this tool here, MathsPad, right? This tool you can use here and you can take the help of this. Okay, what you can do here, you can draw, like if you want to take the same measurement, okay, like 5.5 centimeter ka triangle you can take. like this is what 5.5 centimeter. Okay, we can draw it. Okay, there is no problem here. 5.5 centimeter base we can make, right? This is what our 5.5 centimeter. Now next is what? Okay, we can take we can cut 5 centimeter and 3.4 centimeter, right? So let me show you here only, like how do we do that. 5 centimeter length we can take 5 centimeters. So I hope you know how to make a triangle. Mm, let me take it exactly. Okay, right. So what we do here, I'll make an arc, and then from this side I need to make another arc, which is what going to be how much length? 3.5, right? Let me take it. How much is this now first? 3.5, right? This is our 3.5. So this is what I cut, 3.5. Now we are going to join it. So we join to this here, we join to this here. So I think you know what are the, this is 5 centimeter, this is 5.5 centimeter, and this is 3.5 centimeter, right? Appu has done this. Appu has done this. Appu's triangle. Okay, you can say. Right. Now Tipu is there. Tipu. Right. Tipu will do some work. Okay, let's see here what they're saying. Now Appu has done this work. Okay, now what? Tipu attempts to draw a triangle congruent to ABC triangle, right? This ABC triangle using the information provided by Appu. The game starts. Carefully observe the conversation and their game. Okay, so Appu one side is this much. Tipu within with the information I can draw. Okay, so what Tipu says, okay, Appu said that I have a triangle with this side 5.5 centimeters. So now Tipu can draw what? He can draw 5.5 centimeter like this. And now what is the thing here? He can make so many triangles over it, right? Fine. You have Appu said 5.5 centimeter. He has drawn. He can make so many triangles, right? That is what he is telling, right? But now what further he should do, right? Are you getting it? So this is what, okay, I can draw any number of triangles, but they need to be copies of ABC triangle. ABC, the triangle I draw may be obtuse angle, right angle triangle, or like this. Okay, like this. So many triangles are possible. You can see here these figures with 5.5 centimeter as base. I have used some ordinary length of other sides. This gives me many triangles with the same base, right? So giving only one side will not be sufficient to draw. See, what is the task here? What we want to do here? We want to draw congruent triangle, right? ABC triangle is there, this one. We want to draw a congruent triangle. So this one information is not sufficient, right? Only one side is not sufficient. So we want to get that minimum. What is the criteria? So now what he will say, okay, if Appu says, okay, I'll give you the length of one more side. Take two sides, okay, like he is taking. Now he is taking 3.4 also. Okay, by the way, it was 3.4. I have taken 3.5. So just I'm doing correction here, guys. Okay, I'm just taking 3.5. So, okay, fine. He said, I'll give you 3.5, right? So, fine. He gave 3.5. Then what Tipu did, okay, he he took 3.5, right? Right, 3.5 it is there. So what he did, okay, he did, okay, obviously from this end, okay, let's say this is PQ, right? So what he did, okay, now Tipu did, okay, this length he drawn, right? Okay, now his side, okay, now what is the thing here? You need to understand this. He can make the triangle like this, like this, like this, right? He can join anywhere, right? Now correspondingly, third side has to be what? Like this it could be, right? It could be like this also. It could be like this also. It could be like this also. So again, so many triangles are possible. Are you getting it? This is what the main thing, right? You need to understand that he can draw again so many triangles, right? The problem is what? Okay, let me do this work again, guys. I know. Right, okay, this is what it is there. Now this is 3.5, right? Now, as I said, okay, he can make see, I need to make one of the side as 3.5. So this is 3.5. I have with these all 3.5. Now I can join this third side. I can join here. I can join here. I can join here. I can join here, right? So you can see again, so many triangles are possible, right? Again, this could be sorry, this could be R. This could be again, right? Okay, like it could be R dash, it could be R double dash, it could be R triple dash, it could be R four times dash. Okay, like that it is, right? So many triangles are possible, but which one is congruent? So what is happening here? Can you understand, guys? Okay, even this will not be sufficient for the purpose, right? He will not get the congruent triangle. I can draw several triangles again with the given information. So what is happening now here? If you support my okay, to support my argument, okay, like this, he said with 3.5 I can draw so many triangles, right? Like I showed you here. All right, let me then Appu said, okay, all right, let me give you the length of all the three sides, then so he will get the exactly congruent. I think it should be possible. Let me try now, right? So then he will get excellent. So to draw the copy of triangle ABC, what we conclude here, to draw the copy of triangle ABC, we need to have all the three sides, right? So this is what it is. So did you get the congruency thing, right? What is triple S congruency? All the sides are exactly available in the another triangle, right? So if you want to make a congruent triangle, if you want to make a congruent triangle, so you need to have like 5 centimeter. You need to have like third side is what, 5 centimeters. So I need to cut that much only from the third side. Are you getting it? So if you cut this and then join, that is what perfect. This and this is what our triangle, right? This is what the correct R, right? I hope you got it. So Tipu, when he get this is 3.5, this is 5 centimeter, right? So he got now proper shape, congruent shape, this shape and this shape. Okay, the black one, right? This is what congruent. Why they are congruent? Because it is what exactly sides are given, right? It is just flip. Okay, if you just flip, okay, you have seen last class, we can do the congruency. We can check the congruency by flipping the shape, right? If you flip it, okay, it will come over it exactly. So this is what now these are what congruent shapes. I hope you got it, right? So let me correct it here. The congruency criteria here. Okay, I need to change it. Congruency criteria states that if three sides of one triangle are uh, respectively equal, okay, not proportional. Proportional is for similarity. Equal to three sides of another, then the two triangles are congruence. Okay, congruent. This essentially means that such pair will be equiangular, right? Okay, this is also true, right? So this is what it is, right? I hope you got it. What are we understanding here, right? Now next criteria, I think we should come to the next criteria. That is what? SAS criteria, right? If any two sides, an angle included between the sides is equivalent to corresponding to the, okay, that is what, then they will be congruent. Let's understand from your textbook. I think this is again like it will be clearly explained here also. Okay, you can see this example. Okay, this is what congruency. If under a given correspondence, the three sides of one triangle is equal to three corresponding sides of another triangle, that is what? Congruency, right? Triple S congruency, right? So you can see here, example also you can understand. In a triangle ABC and PQR, AB is 3.5, BC is 7.1, and AC is this. PQ is 7.1, QR is 5, and PR. So you can see like sides are equal, though their naming is like here and there, but they are congruent, right? I hope you got it. Corresponding sides, okay, this side is equal to this side is equal to this side, and this side. If you just flip it over it, right? If you put it over this like this, it will completely overlap, means they are congruent. I hope you understand. Important note, the order of the letters in the names of congruent triangles displays corresponding relationships, right? That is what very important. A corresponds to R, B corresponds to P, C corresponds to Q. This order is important. You cannot write ABC is congruent to PQR. That is wrong. So this is what very, very important, right? I hope you understand this. Now, this example also you can see, right? This is a shape in this figure. AD is equals to CD, AD is equals to CD, AB is equals to CB, AB is equals to CB here. State the three pairs of equal parts ABD and CBD. Okay, so you can see this part is equal to this part is equal to this, and there is a common side. So again, we are taking two triangles, this triangle and this triangle. In these two triangles, what we can see? This side is equal to this particular side is equal to this side, and there is one side which is common in both, right? So they are congruent, right? So triangle ABD is congruent to CBD, right? I hope you got it. AB corresponds to BC, and AD corresponds to CD, right? So that's what. Is ABD congruent to this? Yes, they are congruent. Why? By what criteria they are congruent? By triple S, right? Does BD bisect angle ABC? BD bisect angle ABC? Yes. Why? Because this angle will be equals to this angle. Are you getting me? Let me erase this part. Okay, this is very good example. This angle is equal to this angle. We just discussed that two triangles are congruent, means their corresponding angles will be equal. So this angle is equal to this. So means BD is bisecting this. Bisecting means what? Making it into equal halves, right? Does BD bisect ABC? Yes, it bisects, right? So this is what we are getting. I hope you understand this. You can see these more examples, right? Okay, this figure 7.14. Okay, length of the sides. Okay, see, this is what 1.5, this is 1.5, 2.2, 2.2, 2.5, 2. They are congruent, right? Here 3, 3, 3.5, 3.5, 3.2, 3, congruent by triple S, right? Here 2, and in this there is no way to. 5 is there, 5 is there, 4 is there, 4 is there. They're not. Okay, here 3.5, 3.5, these are equal. This is equal to this here, this is equal to this, and that third side is common, so they are congruent, right? This is what congruency here, congruency here, congruency here. But in this third one, there is no congruency, right? I hope you're getting it. Now in this figure, we have seen AB and AC are equal. D is the midpoint, right? So this is equal to this is equal to this, and this AD is common. So what? State pair of equal parts in this triangle AB, ADB and ADC. So they are state the pairs of equal parts, right? We can state easily BD is equal to CD and all, okay, like that. Is this? Yes, by triple S congruency. Angle B is equals to angle C? Yes, because they are, yeah, by the way, what we say here, what is the reason we need to give? They are congruent part, okay? Congruent parts of, you can remember, congruent parts of congruent triangles, sorry, corresponding parts of congruent triangles are equal. So B corresponds to C, so that's why corresponding parts are equal. So that's why this is what equal by CPCT. If there are two congruent triangles, their corresponding parts will be equal. Obviously, because they are overlapping each other, so they are going to be equal, right? You can see third example yourself. Let's understand further. Okay, the same thing if we do here, right? Let me now change the rule of triangles copying game, right? Okay, go ahead. Okay, you have already found the giving length of the one side. Okay, okay, yeah, giving one side length is useless because we can draw so many. So Appu said, okay, if I just give you 1.5.5, I can draw so many triangles. That is not sufficient, right? In that case, let me tell triangle ABC, one side is this and one angle is what? 65. One of the angle is what? 65 degree. Okay, fine. One of the angle is 65. Again, with 5.5 as base, and one of the angle, base angle is what? 65. He can draw so many triangles, right? So many triangles are possible. So now what is the another information will be required? So he said, so what shall we do? More information is needed, Tipu said. So then let me modify my earlier statement. In triangle ABC, the length of two sides is what? This, and the angle between is what? 65 degree. This information should help me. Let me try. So what he did, 5.5 he has drawn, 65 angle he has made, right? Now what he did, side, one of the side is what? 3.5. Now what he got, exact figure he got. Did you get me? So now he is getting exact copy of the what Appu was having the figure, right? So this is also congruency criteria. This is also minimum information which Tipu will be requiring to make the exact copy of Appu's triangle, right? So this congruence is called as SAS when two sides 5.5 and 3.5 and then angle between them is given, so you can make the exact copy of another triangle, right? So this is what SAS congruency, right? I hope you are getting it. So SAS congruency under a correspondence, two sides and angle included between them is given, right? Angle included between them, right? I hope you got it. So this is what SAS criteria. Same way we have ASA when two angles are there and side included by them. Side included by them is what given, right? So that is also congruency. We have two angles and included side. So that is what we can do, right? We can understand same way. Okay, perfect, right? We understand that. Now I was saying here, I think you remember that I said that we can mark it as, we can name it as, yes, we can name it as, this can be or AAS criteria also. Now why I'm saying that AAS, two angles and one of the side. Why I'm saying that, suppose this angle is what? 30 degree and this is 40 degree. This is 30 degree, or let me take 60 degree, and yeah, 60 degree, and this is what? 40 degree. So how much is this remaining angle? Is it not equal? Is it not coming equal, right? If these two angles are given, this angle is 60, this angle is 60, this angle is 40, this angle is also 40 degree. Now don't you know that by angle sum property we can say that the remaining angle, this angle will be 80 degree, because this will be 80. So this angle and this angle, if it is given, if any two angles are given, so do we know the third angle automatically or not? So angle, angle, and this side, angle, angle, and this side also could be there, right? So both ways it is true. So ASA is indirectly AS also, right? This criteria is also AAS also, right? So you need to remember that these two criterias are same only, right? There is name you can remember as ASA or AS also, should not be confusing for you, right? So this is what it is. So what we need to give, okay, if Appu is having one triangle and then Tipu has to make triangle exactly of same shape and same size, same shape and same size. So what he has to provide the information, two angles and one side, two angles and one side. If I say this is more than enough to cover both the criterias, right? Means they are same actually. ASA, either you can provide two angles and included side, or you can provide any two angles and one of the side, right? That is more than enough, right? So you can try this activity at home, okay, and just understand this, right? Okay, fine. Now last one we have right hand side criteria. Okay, what is right hand side criteria? Right angles hypotenuse side criteria, sorry, my bad. Okay, not right hand, right angle hypotenuse side criteria. So this criteria is applicable especially for two right angle triangles only. It has to be right angle triangle first. If one of the side is given equal and hypotenuse length is given, right? One of the side is given and hypotenuse side is length is given. So you can find out, you can make the exact copy of that. So one side has to be given, one hypotenuse has to be given. One side and right angle will not be sufficient, right? So we need to have one side and hypotenuse. Hypotenuse is what should be equal, right? So this is what the fourth criteria, right? I hope you got it. You have the information here, right? You can again look into your book and you can see the textbook examples also, because it is explained there. Okay, you can see like clearly here, right? Like this. Okay, this is what given. All the criterias are given there. We can see this activity. Okay, now 2.5, 2.5, 2.8, 2.8, but the included angle is not same, so that's why not congruent triangles, right? What about here? 2.5, 2.5. Now this is what 35, 35, 3 and 3, right? They are congruent. They are congruent. So we will write here. Now let me show it to you. This also ACB, triangle ACB is congruent to. Now this AC corresponds to what side? RP, RPQ, triangle RPQ. This is what very important to understand the correspondence, right? CB corresponds to PQ, right? That is what it is, right? So this is what it is. Suppose you want to write triangle ABC is congruent to what? So AB corresponds to what? RQ, right? Are you getting it? RQ. So you'll write here triangle RQP. This is what also fine, right? This is also fine. This is also fine. So triangles, this criteria writing also you should understand. They are, you can see SAS congruence is there. What about here? Is SAS congruency there? Yes. Side is common here, and this side is equal to this and included angle. So this triangle is congruent to this, right? Can understand. Now these two triangles are congruent because vertically opposite angles are always equal. Vertically opposite angles are equal. This side is equal to this side is equal to this, so they are congruent, right? Okay, perfect. Now we come to ASA. You can see, let me take you to the example here. Two angles and included side, two angles and included sides, so they are congruent, right? Here two angles and included side. Oh, okay, it is not included side. Okay, let me show you. What is this angle, by the way? 40 degree. This is 40 degree. You have to remember angle A plus angle B plus angle C in a triangle is what? 180 degree. That's how I wrote 40, 40. So can't you see here 40 and 50 and included side is 3.5. Okay, 40 and 50 included side. Okay, my bad. Okay, I didn't pay attention to that. You need to be careful about that. 3.3 and this is 3.5. They're not congruent. They're not congruent, right? What about here? 60, 36. 60, 36. This is there, right? Now here, what about this one? There is one triangle like this, and there is another triangle. Let me change the color. Like this. What is the angle here? Can you tell me for green one, what is it? 75. 75 is the angle. What is the angle for red one? 75. Included side is common, right? This is common. What is the angle here? 30 degree. For red one also 30. They are congruent. triangle A D B ADB is congruent to triangle CBA, right? This is what it is. I hope you're getting it. Try and understand other examples also. You will understand. I'm sure about that. Okay. Let's see further. These examples also we can do, right? Okay. In this triangle, okay, here this is right angle triangle, here right angle triangle. Whatever is this angle here, that is what same angle here, because this is what given, right? So you can say they are congruent by RHS rule, right? These are the criteria. This solution is given. I believe you can do this, right? Here, let's see this example here. Hypotenuse are equal, right angle is there, and 3 oh no, this is 2.5, this is 3.5. No, they're not congruent. Okay, right angles are there, right? Hypotenuse are equal, common they are, right? Okay, one of the side is common, so congruence is there. What about here? Hypotenuse are equal, right angles are there, 3, this is what there. Here also it is there, right? So I hope you are understanding. You can make sense out of it. So try these questions yourself, right? I believe you will do them. Okay, there is no problem at all. So this is what we have, right? So you can go through it. This is all we discussed. Okay, we can see more examples here. We want to show Q triangle ART is congruent. Okay, guys, here this symbol is what? Congruent. Let me write it here. Yeah. Okay, this is what it is. This is congruent. We have to use SAS criteria. We have angle T and angle N equal, right? There are two triangles. RT, what more we need to show? Okay, so let me show you here. Okay, what is it there? T, angle T. So A R, my bad. 1 second. Let me write it. R and T. And then what we have here? So SAS criteria, we need to show where T angle, this angle. Okay, let me mark here now. This is what it is there. Now, N is what, let's say I'm making here. P, E, okay, like this. They are like this. According to this criteria, I wrote like that. Okay, and SAS. So these angles are equal. Now RT is equals to EN. RT, where is RT? RT is equals to EN. These are equal. What more we need to know? We need to know this side and this side has to be equal. So AT is equals to PN. AT or PN is equals to AT. So we got this, right? I hope you got it. Now let's see here. We want to show that triangle. Okay, let me write here. Triangle ART. Okay. AT is equals to PN and angle A. What congruency? ASA congruency, right? We want to show. So let me make it here. This first triangle, then another triangle. ART. A. My bad. Okay. I'm making it B again and again because ABC generally we make. That's why. Okay. Let me not do that. ART. And which angle? Angle A is equals to, okay, this angle is equals to P, right? This one. Now here, okay, so AT here, and this is what N. This is what given. Now this is what ARPEN, right? Okay, this is what given to us. ASA congruency we want to show. So angle. So what else we need to know? This angle we need to make equal because side is given. So ASA. So T, angle T is equals to angle N. A option, right? I hope you understand it. According to given condition, I made the triangle, then I can see easily, right? Okay, now this one, which congruency criteria do you use in the following, right? Which, so what is it given? AC is equals to DF. AC is equals to DF. AB is equals to DE. AB is equals to AB is equals to DE, right? We have AB is equals to DE. Now BC is equals to EF. BC is equals to EF. So which criteria you can see? Triple S, right? Very simple. By they are congruent by triple S, right? This is what we are getting because sides are equal. So this is what there, right? You can practice more questions, obviously, students. Okay, I hope you got the idea. You understood it clearly, right? So do more practice so that you can understand the topic clearly. Okay. Thank you very much. All the best. Bye bye.